Welcome to this explainer. All right, let's jump right in. If you're heading into the final stages of your Information System Engineering Master's program, you're probably staring down what feels like the biggest hurdle of your academic life, the research proposal. But you know what? Today, we're going to completely change how you look at that challenge. Instead of seeing it as this massive, terrifying wall of paperwork, we are going to transform that proposal into a clear, actionable blueprint. Think about it. An architect wouldn't even dream of building a skyscraper without a meticulously drawn plan, right? Well, you shouldn't launch into your MSc without a rock-solid foundation either.
Because when you're designing a functional project at the master's level, you really aren't just writing an essay. You're taking a high-level academic theory and actually translating it into practical, real-world, often local applications. And the whole goal of your proposal is to bridge that gap. It's about looking your faculty supervisor in the eye and convincing them that your technical ideas are completely sound, your methodology is crystal clear, and most importantly, your project is actually achievable. You're taking abstract concepts and moving them into a structured physical reality. So, here is our roadmap for getting there. We've got 1. The backbone of research. 2. Finding your perfect topic. 3. Mastering the literature review. 4. Framing the research question. And finally, 5. Anatomy of a proposal. Let's kick things off with part 1, the backbone of research, establishing your guiding philosophy. Look, before you can build the walls, the roof, or any of those cool smart integrations of your engineering project, you've got to have a solid underlying structure. And in academic research, that foundation is your philosophy. The source material captures this perfectly, stating, philosophy is the backbone of research design. Without philosophy, anything we do as researchers is pretty much meaningless and empty. Now, I know that sounds pretty deep, right? Almost intimidating. But practically speaking, your research philosophy just provides the essential direction and guidance for your whole engineering project. It literally feeds into every single aspect of your research design. If you don't know why you're approaching a problem a certain way, or what your underlying assumptions are, your final project is just going to lack cohesion. Think of your philosophy as the compass that keeps your project from drifting off course.
Which brings us to part 2, finding your perfect topic, navigating the selection process.
Once you've got that foundational philosophy locked in, we move on to the framing stage of our blueprint. This is where you systematically choose a topic strong enough to actually hold up your research. And a quick reality check here, you can't just pick a topic because it sounds cool. It has to pass a pretty rigorous test. First off, it absolutely must be relevant to current challenges, things like project delays, sustainability, or safety. Second, it's got to be feasible. Do you actually have the data, the time, and the resources to pull this off before the semester ends? Third, you need originality. We definitely want to avoid those exhausted, overdone topics. Fourth, it really has to match your personal interests, because honestly, your curiosity is the only thing that's going to keep you motivated when the work gets tough. And finally, it needs a well-defined scope. You want to avoid topics that are way too broad or way too narrow. For an engineering topic to be successful, it's got to be both manageable and practically significant. Now, finding that perfectly scoped topic, it doesn't happen overnight. You have to brainstorm. And good brainstorming always starts broad. Just look at this spider diagram exploring why penguins make great pets. It's funny, it's totally lighthearted, but it brilliantly illustrates a fundamental research tool. You start with this one core idea right in the middle, and you just let your mind branch out into related themes. Like they're sociable, they're funny, they're black and white. When you're trying to identify a broad area of engineering study, use simple tools like this. Let your creativity flow first before you apply all those strict selection criteria we just talked about to narrow it all down. And when you do finally narrow it down, you really want to land on something with a real, tangible impact. Our source material gives us some fantastic, locally relevant examples of what this looks like in the real world. Just imagine designing a cloud-based ERP system that's tailored specifically for small enterprises in Nepal, or maybe developing a mobile app for disaster management. Or if you're looking at broader electrical engineering solutions, how about smart grid technologies to optimize energy distribution, or designing new electric vehicle charging infrastructure? These aren't just abstract ideas floating in the clouds. They are concrete, highly practical engineering solutions designed to solve very specific, localized problems. All right, moving on to part 3, mastering the literature review, understanding the landscape. So before you start breaking ground on your own unique solution, you have to survey the construction site to see what other engineers and researchers have already built in your field. I think a lot of students assume a literature review is just, a reading list, but it's actually a highly systematic build. It's a clear 5-step progression. First, you search for relevant literature. Then you critically evaluate those sources. Step 3 is where the real magic happens. You identify themes, debates, and, this is the most important part, gaps. What hasn't been solved yet? Once you spot that gap, step 4 is to outline your structure. And finally, step 5, you write it up. Your literature review essentially proves to your supervisor that you actually understand the current landscape, and you're not just out there reinventing the wheel.
That takes us to part 4, framing the research question, defining your core problem.
Finding that gap in the literature leads us exactly here. This is the structural gap that your specific research blueprint is designed to fill. So I want to pause for a second and just ask you to reflect on this directly. What really makes a good research question? Think about the projects that naturally draw you in. Are they just summarizing basic facts, or are they actively pushing the envelope? Because a truly strong research question has to do some heavy lifting. It should aim to extend current knowledge or completely close that gap you found during your literature review. It needs to solve a definitive, specific problem. But check out those last 2 points. They're super fascinating. A truly great question might open up the topic to entirely different approaches, or, get this, even disagree with, contradict, or point out inconveniences in current research. Your research question shouldn't just play it safe. It should push boundaries and fundamentally challenge our assumptions.
And finally, part 5, anatomy of a proposal, the SHEMS case study.
We have finally arrived at the architectural payoff. We've talked about philosophy, we've covered finding a topic, reviewing the literature, and framing the question. Now we're going to reverse engineer a completed gold standard proposal to see exactly how all these theories apply in the real world. This is SHEMS, which stands for Smart Home Energy Management System. Look at how beautifully specific this project objective is. The goal is to design a system that optimizes energy consumption, cuts costs, and promotes sustainability, specifically at Kathmandu Engineering College. It literally checks every single box we discussed earlier. It has a well-defined scope, it's incredibly relevant to current challenges like sustainability, and by targeting their very own college premises, it guarantees both feasibility and data availability. It's brilliant.
And this illustrates perfectly how an overarching philosophy gets broken down into tangible, actionable engineering tasks. To hit that objective, the proposal outlines some very specific steps. The students have to develop a system architecture tailored just for the college. They need to design a user-friendly interface so the staff can actually monitor energy usage in real time. They've got to implement data acquisition from physical sensors placed all around the campus, integrate renewable sources like solar panels, and even establish the protocols needed to communicate with the external power grid. See? There is zero ambiguity here. It is a precise, step-by-step engineering plan.
Finally, a top-tier proposal tells the supervisors exactly what they're going to be handed at the end of semester defense. For the SHEMS project, the deliverables are crystal clear. We're talking tailored architecture documentation, actual UI prototypes and software, custom energy analysis algorithms, real-world test results actually conducted on the college premises, and, of course, a final comprehensive report. This right here represents the fully built academic structure. The blueprint has officially become a reality.
Well, we have covered a ton of ground today, going all the way from the philosophical backbone of your MSc research right down to the exact deliverables of a functional smart energy system. By applying these strict criteria we've discussed, you can guarantee that your work isn't just going to be some empty academic exercise, but a highly targeted, deeply impactful project. So, as we wrap up this explainer, I want to leave you with one final provocative question to think about for your own journey. What local, real-world problem are you going to solve with your new research blueprint? Get out there and start designing.